Hi, welcome back to the Chicago Math Lab differential equation problem solving session. So here is the differentiation problem. We're going to solve it. It's ty prime plus 2y plus t squared y cubed and et with the initial condition y1 equal to 2. Okay, so now let's go ahead and get a start. And first, let's observe, take a look at these problems and see what type of the method we're going to use. And so the first thing is here, the student constantly asks me, how do you know which method to use? And here is what, we first, kind of like the detective, let's examine of a problem and find out the possible solutions here, all right? Okay, there we go. So the first thing is here, let's observe the y terms here. So this is y prime, this is 2y, this is y cubed. So this is pretty good. This is like the linear term. They don't have like a y and the y prime linked together. Then the next things we find out is also it's pretty good is the constant the number function in front of the y is like it's always a function of the independent variable t's here, like a d phi, t phi, et, t. So we know this gives us a pretty good candidate by using the Bernoulli equations here. All right, so let's take a look at the Bernoulli equation. So it's the dy dt, right, plus pt, and is the qt, and to the y the nth term. So this will be a good candidate. So we can start to try to use the Bernoulli equation to see we'll be able to solve it or not. Okay, so in here, if you take a look at the Bernoulli equation, the dy dt in front of it is 1, right? So does not have variables there. So the first things we need to do is get rid of this t, right? So we divide by t both sides here. All right, so here you will get a y prime. Y prime is dy dt. Then plus this is 2 over t and the y. Then also the Bernoulli, I need to move this term to the right-hand side. So this will be negative. T and t fifths will give me t fourths. And then et, let me rewrite it the order. So this is a y cubed here. So as you can see, this matched, this matched the Bernoulli equation quite well. And also let's observe it. So I know this one's here, this is my PTs, right? And this one's here, this is my QT, and my nth here is what? My nth here is 3. All right, so that's good. And so now let's go ahead, follow the step. Remember we say, okay, as soon as we decide we want to use the Bernoulli, so step number 1, let's define a new function, new variable v. So what is the v here? V will be equal to the y, the 1 minus m. So it's y, the 1 minus 3. So this is y, the negative 2, or you can put it y the squares, right? Then let's take a look. So what is the next things we need to do? Step number 2 here. Let's take the derivative of the v. So this will be dv dt will be equal to, this is a negative y to the negative 2, right? So the derivative will be negative y to the negative 3 dy dt. And after we do that, we want to find we want to replace the dy dt to a function of the dv dt. So what do we need to do? See here. So what I need to do, I want to times. So basically, I want to times negative 1/2 to both sides here. So I will have a negative 1/2 and the y cube. All right, negative 1/2 y cube, the dv dt. Then the right-hand side here, so this is negative 2 y the cube, negative cube, and then you times negative 1/2 y the cube, then dy dx. See here? All right, so now in here you see these numbers here. These numbers, negative 1/2 y cubed and the negative 2, cancel that out. So now this is how do I change the function dy. So this is my step number 2, right? So this is a dy dt is equal to the negative 2, negative 1/2 y cubed, all right, dy dv dt. So remember, if it is a Bernoulli, we always follow the same process step. So we replace, so the step number 2 is change the dy dt, a function of the dv dt. All right, so then the step number 3, let's substitute back to my original, the equations here. My original equation is dy dt plus 2t y equal to the negative t4 e to the t y the cube. So what I want to do, I want to replace here. All right, so here I want to replace the dy dt with this number back to my equations here. Okay, so now let's do that. So dy dt is equal to negative 2 y cubed dv dt. Right, so all the other remain the same. So 2ty is equal to negative t4 et y the cube. Okay, so now I want to change back. I want to change to the simple linear first order differential equation for the dv dt's, right? So what I need to do, okay, as you can see here, I need to get rid of, I need to get rid of these constants in front of my dv dt, all right? So now what I need to do, I will divide by negative 2. So what I can do is I will divide by negative 2 y cubed on both sides, negative 2 y cubed on both sides here. Okay, so now let's see, after I do that, what happens here. All right, so here, the dy, so this one, of course, become 1, right? And then this one, negative 2, then this y and this y cancels here. Okay, so now let's rewrite this ones here. So this one, okay, so after this one, we'll see here, this will be my dv dt. Okay, now I have a 2 and the negative 2 here, so will be the negative, right? So this is negative 2, and so here this is y, so I'm going to have a y squares here, okay? Oh, I just noticed here, made a silly mistake here. This is negative 1/2 1 cube. So I need to replace it. So here, this is my little mistake. Here is negative 1/2 here. Okay, so I need to divide by, okay, so here, I just noticed it. So I need to divide by negative 1/2. All right, much better. And I need to divide by negative 1/2 on both sides here. Okay, so now this is much better. So this is negative 1/2 still cancel. Now this is y cubed and y become y square. And then this is 1/2 and 2. So what's going to be here? So going to have a 4 here. Now I still have a t here. right? Okay, so my right-hand side is here, y cube cancel, negative and negative cancel, and then 1/2 flip. So will be 2t4 et. Perfect, right? So now this one's here. Okay, so now this one's here. We know 1 over y squared. So this will be dv dt minus 4 over t. Remember, v is equal to 1 over y squared. So this is the v's, right? So this will be equal to 2t4 et. So this become a very so this become a simple first order, the differential equation. So after we do that, we change it to this nice form. So remember the next step here, we need to find the integration factor. All right, so how do I find the integration factor? So I need to use the du, I defined a du dx is equal to my PTs, right? The one is equal to my PT, and it's the one, the new PT. So this is my new PT for the V's, right? All right, so it will be negative 4 over T and times U, right? So what do we want to do? We want to solving for U. Okay, so this is kind of the important steps here is like, after you change that to the simple first linear, like the order of the linear, the differential equation. So this is how do you define how to find the integration factor. This is a kind of important step. So I want to solving for you. So this one solving for you, you can use a separation. So du over u is equal to negative 4 the t. I'm sorry, here should be dt. So dt. All right. Then you integrate both sides. So you integrate both sides, and then you're going to have this is a natural log u, right? So here, okay, so this is a natural log. So this will be natural log u is equal to natural log t to the negative 4 power. So I can get it that u is equal to 1 over t fourth. All right, so this is equal to the 1 over t4. So like I said, this is a very important step. So this is my integration factor. After I get that, so what we need to do is my next step, I need to multiply the integration factor to the both side, right? So I will need to multiply the u on both sides in the equation, the number 4 equations, right? So that's what the integration factors help us. So this will be 1 over t the fourth du dt, and okay, so it's a minus. Okay, so minus. I'm sorry. So it's in the equation number. So here, let's call the equation number 3 for my original. Okay, equation number 3 to the equation number 3. So I want to substitute back, right? So be careful here. I want to substitute back to the less equations here. Okay. All right, so now let's go ahead and continue here. So it's 1 over t4 du dt, and so the dv dt, okay, then it's minus 4t. All right, so minus 4, And because it's 1 over t4, this is 1 over t, so it's 1 over t5, right? Then 1 over t5 v, and then here 2t4 et. So 2t4 et times 1 over t4. So here cancel. So what I have here, so my left-hand side have 1 over t4 dv dt minus 4 over t5 v is equal to 2et. Okay, then remember here what we said, this is the integration factor. So the reason why we do that, we can change this to be the, so we'll say this one here is 1 over t4 times v. You take the derivative, right? So if you take the derivative, so this here, so this will be the product rule, right? So take the derivative of the v, so it's dv dt, hold the second one, then plus, hold the v, take the derivative of 1 over t4, so it's negative 4 to the t to the fifth. Then this one will be equal to 2et. Okay, after we do that, then what do we need to do here? We integrate, right? So we integrate these terms here is dt, then 1 over t4 v, and we need to integrate both sides here, and this one's here, when we integrate, this will be the 2et integrator, right? So you integrate 2et. All right, so this one is the, you integrate a derivative, so it will just be what? So it's just by itself, right? So it's 1t4 times v equal to the 2et plus c. All right, so it's pretty good. So v is here, so now I can times the t4 both sides, right? So get rid, so it's v is equal to 2t4 et plus ct4. Now, what is my v at the very beginning? Is 1 over y squared, right? So it's 1 over y squared equal to 2t4 et plus ct4. Now, I substitute my initial condition, y1 equal to 2. So here, y equal to 2, so it is 1/4 is equal to 2 times 1 to the 4th, either 1, plus c times 1. So you will get what? 2e plus c. So what is my c? c is equal to the 1/4 minus 2e. So finally, you get my answers, right? So here, I will have 1 over y squared equal to, I can take the t4s out, then this is 2et, and plus 1/4 minus 2e. Right, so I just substitute the c back to what my equation, so I can get my solution. So now I know the y will just be, you take the square roots and you flip it, right? So here is you flip it, then this is a t4, 2et plus 1/4 minus 2e. Ta-da, we finally finished. It's a little bit tedious, but as long as you follow the same steps, right? Define the v, and find the integration factor, and substitute back, and you will get it. All right, I hope that this will help you to work on this problem. Okay, talk to you in our next homework work sections. Yeah. Okay, bye. See you next time.